I would have that. Everything else is 0. So I'm just going to take that matrix and stack it on top of the other. That's what's happening. And whenever you have the two elements overlaying, you add them together. That's all that is happening right there. So to build a k-local matrix, you really express your local matrix in global element, in global nodes like this, right? And then you just overlay them together, one on top of the other, and whatever you have two elements.
So are we going to be using for loops in this and stuff?
Right. So actually, let's see what time is it. I'm probably over. Okay. So remember the very first homeworks that you were tortured in with MATLAB, where you had a small little matrix and you could build larger matrices? You have to come up with an algorithm that does this stuff autonomously. So essentially, you can do it either for loops, using for loops or structures. So I recommend that you start by, right off the bat, by defining your K matrix, K global, whatever. Well, first of all, you calculate K local using integrals, whatever. Just evaluate that. That should be fine, symbolic, or whatever. You initiate K global to be zeros of size n+1, where n is the number of linear elements that you have, like mesh of 4 elements. So if n is 4, then you have 5 by 5 matrix, right? And then you can run a for loop or whatever to fill up the elements. So you'll have like.
What if it's not a linear element?
Like trusses? Then you'll actually export this later.
Like the 3 pieces that we have.
So
all, do you know if all, I haven't looked at all of our homework. I know the first problem says it's linear. Is all of our homework linear?
No. Choices will be non-linear. So you can come up with either algorithm to put everything by hand. You'll just have to tell it which element it is, which color it is. It's possible, it's doable. I have a code that does it.
Sure you do.
But for the but anyway, for the mesh of the linear elements, because they are overlaying, because when you're going to build this matrix, because they go like this, you can actually use just a simple for loop to
we have that coded already.
The way I did this back in the day, I think is that I know that I have diagonal 4, diagonal 3. You can just fill it up whatever algorithm you want. Now the big. Okay, so is everybody okay with the with building K global matrix?
Yeah.
You probably have it already. Now the big landmine is the other integral. This one. Right. But anyway, it's this integral right there. W x squared. K to W. You have to compute this. Recompute this for every element separate. So, like for this one, xa would take on a value of 0, and this would be like whatever. When you proceed to this guy, that the values change, so you have to recompute this every time. Let me write it down, and I'll show you then how to actually get the solution. I have the code that runs. I will not show you the code, but I'll show you what to do once you have that K and once you have that F. So you guys can hang around for 2 more minutes. Anyway, so for the first element, F1 is going to be integral of SA, xb, x.
Oh, you're welcome.
Plus W dx. And again, remember that you will have to, your K local, you'll have an F local matrix which will contain actually 2 values, because you can either plug in one interpolating function for W or the other. So you will have to be aware of that.
W being psi.
Yeah, psi 1 or psi 2, you can, you have two different choices. So really,
Same as piccolo.
let me change this notation.
But if the original equation doesn't have an F in it, then it doesn't. Then
Right.
F is 0.
Then you're lucky.
Yeah.
If,
We have this.
but you do have enough. You got an X square there. So now
This is our homework. We have this in our homework.
There's one, this is either from the one that has an X squared.
Okay.
Right. So the general idea is that you got for every element you got like this stuff. Say
Longest Friday
right, psi
ever.
1.
Longest Friday ever.
That's okay. So you crunch this, crunch that. Boom, done. Then you can build the F global matrix. What the F global matrix is just you just sum these forces up. You know, again, like all related together, you get the F global. Same concept.
No idea.
Now, at the end of the day, at the end of this procedure, you get something that looks like this. So you got your global K global times U1, U2. Actually, let me write this actually. Rules. So again, 1, 2, 3, 4, 5. 5. Okay, all of these elements right here are numbers, or there's some stuff. I'm just gonna put, something in there. Letters.
We didn't say I'm correct about the Kowalski.
I mean, some numbers. I'm just filling this up. So that you don't think that it's 0. And you multiply this K global by U1, U2, U3, U4, 5 equal global F1, global F2, global F3, global F4, global F5. All right? Now, how the hell do I solve
Where's the
that?
plus Q? Is that
Plus-
included?
Plus Q goes
Yeah.
in there, but actually Q drops out for now. You don't have a Q in
In this one, you mean?
Right, in this problem in particular, you don't. Q we'll calculate later. We got the Q, but it's derivative of Q. It's not.
So it's not a factor in
Right.
this.
We clutch the solution so that it looks like a Hooke's law. Kx times
Okay.
Kx is also.
Looks like a balloon
That's the point of this. Now, remember, we're given the boundary conditions right here, right? Your U1 represents the value at the first node. U5 represents the value at the last node. So we know that we're given the solution at the first node and the last node are 0 and 0. Okay? Everybody's good so far?
Mm-hmm.
If you can't, well, okay, if you just get this K global, get this K local, get this K global matrix, get this K global matrix. If you just do back division in MATLAB to solve for the 1, U2, U3, U4, U5, you're going to get zeros. So to get around that, you do condensed equations. So since I know what U1 is already, and since I know what U2 is, U5 is already, you're going to just disregard everything that has to deal with just disregard it. And also kill these two rows because they have to deal with U1 and U5. Is everybody good?
So that like B multiplied by E2 and like C multiplied by E3? Like the first column?
I get rid of them because, you know, it's the first row that has to deal with U1 and F1. I'm not looking for U1 and F1. I don't need to know what F1 is or F5 is. Well, actually, I know what F1 is and F5 is. I know this.
Since we're calling U1 and U50, we also know about F1 and F5.
Well,
and that's why we get
all
the
of this is
double
known.
round.
We calculate this. I want to solve for U2, U3, U4. If you just do a back division, you're going to get everything as a 0 because that's not a solution. So the way you get around this, you cross-solve the equations with known boundary conditions. Now we have condensed equations. So we have this smaller k, and you've got this smaller u, and you can solve this by back division. And boom, there's your answer for u. Back division. You just say, you know, my new k, and that's how you get it. And after that, you can, if you're interested, you can also calculate q by two methods. Q is nothing more than, you know, global node minus like one global node over the other node over each. And there's another method to solve this for Q. It's in a book. Anyway, let's see if this works actually. Unfortunately, I cannot show you the code, but I can answer now generic questions. But this comes up. I'll show you how you can easily solve.
Can you get comfortable?
I checked that out. Yeah, it wasn't as bad as I was thinking it was gonna be. I didn't get my matrix, my C and D matrix.
Flop. What's up?
No, it should have been K something, it would have been like K plus something, because that was attached to the Y, right? Whatever was attached to the Y, so
Wait, are we done?
and I think the C was 0.
I can't tell.
I went to her, I still didn't.
There should be something like comes here with y. This is y, depends on where y is. Because if y is farther down, it's
And every time you proceed to the element, just make sure it's just overwrite.
Dad, mad dad.
So the theta then. So you're looking for theta then.
yeah, some data and some.
So I said I want X and Y, I put ones in those columns for the C, you know, like 4 by 2.
Please stop
She said it was only, it might be 0, then it was like 4 by 1.
Did you solve it?
I didn't even put you.
Oh, you mean, no,
Didn't
you're
put you.
right.
I said J.
If you did it though, there's like, you get most points. You know, like most of the points.
I said R squared.
Oh, I didn't even come that close, because I knew it was D.
I don't want to hear this right now.
Okay, I don't know why it doesn't work. Please show me the code. I'll just show you. I guess if you
And I said, I'm trying to integrate it in DL, and I was like, oh, DL, but that doesn't come up with natural log. Yeah, well, yeah, and then I didn't know, I wasn't even thinking about R squared DR, you know what I mean? And so I was like,
You need to change the DM to some times DM.
Okay.
Yeah, I just don't know.
Erase this. Click on the right.
I thought it was R.
You sit in front of me for the systems.
over L.
Those F's are additive, your local F, your big F1 is F11 plus F12.
You overlap. Except from the first element, the second element.
The DM.